video number 12, rate of change video number 12. It's about ladder. I think so I solved this video before. It's on video. It's all right. Let us solve it again. A 13 feet ladder is leaning against a vertical wall. The foot of the ladder makes with the horizontal floor is theta. So let me first draw the horizontal wall, and the horizontal wall, for sure, it represents the x-axis, right? It represents the x-axis. Uh, okay, let me try to draw it this way. All right, we have a vertical wall, and we have the floor, right? We have also the floor, right? And we have a ladder leaning to this vertical wall, right? So this is a ladder, right? Whatever, this is a ladder leaning to a vertical wall. Okay, this is the y-axis, we can consider it, and this is as an x-axis for sure. 13 feet ladder, so the length of the ladder is 13 feet leaning to a vertical wall. The angle the foot of the ladder makes with the horizontal floor is theta. This angle is theta. If the top of the ladder is sliding down the wall at a rate of 0.5 feet per second. So the ladder, the top of the ladder slides down, right, in a rate of 0.5. The rate of this sliding is 0.5. So this is simply the change of y in terms of time, because it's 0.5 feet per second. So change of time, the change of y of the vertical line according to a certain time. That's great. What else? Sorry, if the top of the ladder is sliding down at the wall of the rate 0.5 feet per second, how fast is theta changing? What will happen to theta? What happens to the angle what happens to the angle theta if this ladder slides down? So the angle theta, for sure, it will be decreasing, right? It decreases, okay, because the ladder will be something like that, so it will be a little bit smaller and smaller and smaller as it sliding, as the ladder slides. So what is this change? That's what he's asking about. How fast is theta changing? How fast? So the rate of change of theta, so the theta to dt in terms of time is equal to how much? That's what we have to find. If uh, uh, when the top of the ladder is 5 feet above the ground. The top of the ladder is 5 feet above the ground. So this is gonna be 5 feet above the ground. That's great. So let us start. Um, L is the length of the ladder, right? So we can say sine theta. We can use sine theta. Why using sine theta? Because logically I have the opposite, which is 5 feet, and I have the length of the ladder, which is the hypotenuse. So opposite over hypotenuse is sine. So we start the sine theta, simply it is equal to y over L without substituting any values yet. So we cross product to get y equal, right, L times sine theta. If we differentiate both sides, this is the easiest way, the fastest way to find our answer, to differentiate both sides of this equality according to time. Why to time? Because we already have dy to dt. So differentiating both sides according to time, this L is a constant number, we can leave it outside, and we can derive sine theta to dt also, right? So we got what? Simply dy to dt is equal L times, what is the derivative of sine theta? It's cosine theta, right? and what left is the derivative of theta in terms of time, and that's what exactly we need. We need to find the derivative of theta, d theta to dt, the time, the rate of change of this theta according to a given time. So d theta to dt, d theta to dt is going to be dy dt, dy to dt over L times cosine theta, right? Now, L is equal to 13 feet, that's given, right? But we don't have cosine theta. We don't know what is cosine theta. Simply, sine theta, we just said that y equal L sine theta. This means, can we find sine theta, which is y divided by L? The y is 5 feet. We are finding theta when the y is 5 feet. This is the given over L, which is 13. So 5 over 13. If we have sine, we know that sine square theta plus cosine square theta is equal to 1. Now we can find the cosine. So cosine square theta is 1 minus sine square theta. This means that cosine theta is radical 1 minus, right, sine square theta, which is radical 1 minus sine square theta. Sine theta is 5 over 13, right? We don't need the feet over here, right? It's 5 over 13, so 25 over 169, the square of this number. This means that cosine theta is equal to radical 169 minus 25 over 169, which is equal to radical 144 over 169, and that is 12 divided by 13. So I did find the cosine theta, which we need to go back upwards to find d theta to dt. Now, what is dy to dt? It's given. dy to dt is given 0.5, right? He gave it to me in the beginning, 0.5. So we put here 0.5. We will put the units when we finish. L is given as 13 because it's the length of the ladder, times 12 divided by 13, which is cosine theta. I just found it over here, right? So that is equal half, right, over 13, 13 cancel over 12. In other words, times 2, it will be 1 over 24. 1 over 24, this is my final answer with the unit radian, because it's theta, angle per what? Per seconds. This is change of theta according to time. And that's it.